All right, hello everyone. So today we have the following calculus problem. Find y prime or dy dx for the equation cosine x plus y equals x squared y squared plus e to the y plus x squared. And we're essentially going to be doing an implicit derivative here because y is not written as y is some function of x, which in other words, something like this. So we're going to do an implicit derivative. Now, what does that really imply? How is that different from a regular derivative? The biggest deal here is when you take the derivative of some term that has a y in it or an expression with y, you're going to put the a dy dx next to it. So for example, if I had y squared and I ask you find the derivative of that, your derivative would be 2y times y prime or 2y dy dx, whichever you prefer. And that's the biggest difference, I think, between this and a quote-unquote regular derivative. What you learn is that because you're assuming y is a function of x, you just take the derivative of the expression of y squared, which would be like 2y, but you put a y prime next to it. And that has to do with the fact that y is really a function of x, and you're really doing chain rules when you're doing derivatives of y. So terms involving y, excuse me. So I won't get into that because it's kind of beyond the purpose of this video, but just take that in mind. All right, so let's go ahead and get started. So if I want to find dy dx, I'm going to start by taking a derivative of both sides. So the derivative of cosine of x plus y, let's start with the left, would be a chain rule. So the derivative of cosine is a minus sign, and I would keep the inside times the derivative of the inside. So the derivative of x is 1, and the derivative is 1, y is 1 as well, but because I'm taking a derivative of y, I put a dy dx next to it, or y prime, whichever you prefer. Okay, and that would be it. So all the rules that you've learned so far apply here. So the next, I'm done with the left, so I'm going to work on the right, and I can go ahead and break this up into the derivative of these three terms right here. So we concentrate on the derivative of x squared y squared for a second. That would be a product rule. So the derivative of x squared, let's start with that, would be 2x. So 2x, and then I hold the y squared and multiply it. Plus, now I take the derivative of y squared, which would be 2x squared y times y prime, or dy dx, excuse me. Let me write dy dx to be consistent. So we're done with that. So once again, because I had a product of two functions, x squared is one, y squared is the other, I had to use a product rule. And for e to the y, it would be e to the y times dy dx, because the derivative of e to the y is just e to the y. And finally, for x squared, it's 2x. So we have our derivative. So in itself, with the calculus, you're done. One of the other challenging things, besides the actual calculus with the derivatives with these, is the actual algebra. So my goal now is to get an expression for which you have dy dx isolated on one side equal to something else on the other. So I have to get to work with that. So what I'm going to do here is I'm going to start by distributing this negative sign of x plus y here. All right, so when we distribute that minus sine xy, you get this expression down here. Okay. And my next task will be to get all the dy dx's on one side and everything else on the other. Okay, so I'll try and isolate dy dx. So what I'm going to do here is I'm going to add this minus sine x plus y dy dx to the other side, and I'm going to move the 2x and the 2x squared y squared onto the other side. Okay. And I think this is just the easiest thing to do. So let me write that down. So I would have sine of x plus y minus 2x y squared minus 2x equals 2x squared y dy dx plus e to the y dy dx plus sine of x plus y dy dx. Okay, so if you have a chance here, I'd just go ahead and maybe stop this video and just work on it yourself so you can see that. And then I can't add these terms, but what I can do is I can factor out a dy dx out of this whole expression. You would get 2x squared y plus e to the y plus sine of x plus y equal to minus sine xy minus 2xy squared minus 2x. And last but not least, to isolate dy dx, you will just divide both sides by the expression that you're multiplying dy dx by. So dy dx would equal minus sine of x plus y minus 2xy squared minus 2x all over 2x squared y plus e to the y plus sine of x plus y. And we are done. We have dy dx. Sometimes you could simplify a little further. So I could factor, for example, a negative out of the numerator. However, is that really going to help you or not? I'd say not really, in terms of it's not going to lead to anything else. But just to be, you might already know this from the derivatives, when you're working with your teacher or looking at the answers in the back, sometimes they'll simplify your derivatives as much as possible. Okay, so that is how we do an implicit derivative. Okay, thank you for your time. Hope this helps.